Hi everyone, my name is Jeffrey Lamb.
Jacob Juarez.
Gerardo Alonso.
Singh.
And we have made a data logger, specifically a dual channel data logger that can be inserted between two communicating devices and will record all data transmitted and received between each device. Our device can receive data at up to a megabaud, which is roughly a megabit per second on each channel. This data is then recorded to an SD card. Our device can understand RS-232, RS-422, and just straight up direct TTL communications, and can be battery powered or powered through a USB, which also serves as a configuration port for the device.
For the software aspect of the project, the software is written in C and compiled using Kill Compiler for ARM embedded devices. The incoming data was then received through two UART pins on the MCU, and that incoming data was then written to an SD card over a SPI connection. We also wrote timestamps to the SD card as well for so that the user could also interpret the data that had been written to the SD card.
To achieve this, we incorporated a FTDI chip to allow serial communication, a buck topology voltage regulator to supply a load of 3.3 volts, an SD card slot to write the data, LED lights to identify between configuration and logging mode, and then use JTAG to flash our microcontroller. And also we included jumpers throughout our board to make debugging easier.
As for our inputs, we used two Harwin connectors and two Fisher connectors connected in a passive configuration, and the board tees off those connections in order to take input. The Harwin connector provides the RS-232 and the direct TTL input, and the Fisher connector provides the RS-422 input. Now, our MCU can only read UART, it has two UARTs, those are the two data channels it reads, and those need to be TTL, so the RS-232 and the RS-422 signals need to be converted to TTL. This is achieved by using transceivers, and to allow the user to choose which type of data they want to read, we use mechanical switches to let the user choose which data stream to put on which UART.
All right, we are now open to questions.
Go ahead.
Why did you choose these particular connectors? Are there any equipment that this data logger needs to connect to?
So our corporate sponsor is VectorNav, and they have a line of positional detecting devices, and their devices have two types of ports. They have Harwin ports and they have Fisher ports, and so that's why our logger has these ports.
So what kind of tests did you do to maintain signal integrity between the devices?
So our main test was using the VectorNav's device, which is called a VN100, and it outputs TTL data, and what we would do is we can configure the device to output data at incredibly fast speeds, up to 3 megabaud, and we would run this through our device. The data packets that come from the VN100 have checksums on them, and so we would know if we lost any data because we could parse the data and make sure.
Did you not use any test instrumentation at all, like lie diagrams or something like that?
I'm not sure what you mean.
Okay, it doesn't matter.
So in the real world, you have interference and you have signal degradation and you have environmental factors that affects the signal that comes in. What kind of accuracy did you see as a result of it, and what kind of interference mechanism did you simulate to see whether you're getting 100%? Because the entire goal of your product is high accuracy, error-free data log. What did you try there?
So our device is designed to be put between two very closely connected devices. As for signal interference, that's something we haven't tested.
All right,